The way to think about it is that omega-6 is an essential fatty acid. We need it for life. Without it, we die. The problem is that when we consume it from seed and vegetable oils, we consume it in an oxidized form. The best way to actually get it is from fresh food. So meat, so grass-fed meat's got both omega-3 and omega-6. And if the omega-6 or any of the polyunsaturated fats in that meat becomes oxidized, that meat would be rancid. And we don't eat rancid meat. We don't have rotten food. So if you're getting your omega-6s and omega-3s from natural food, then it's very unlikely to be oxidized. So that's a perfectly healthy way to get it. So fresh fish, don't have rotten fish. It's really quite obvious. So you mentioned canola oil. So it's interesting that you bring that up, because that's actually the one vegetable oil, or seed oil, it's really a seed oil,
Right.
that actually has a reasonable amount of omega-3s in it,
Right.
A 2-to-1 ratio. And when you look at the data, canola oil is really no healthier than any other seed oil. So it really speaks to the point. It's not the omega-6s and 3 ratio. It's the fact that you're consuming oxidized products. And this is why, because most oils, however, are highly, they have a bias towards having far more omega-6s, that when we look at something called the fatty acid omega-6 to omega-3 ratio in your red blood cells, that people with a very high ratio are actually usually in far worse health. And that's simply because this ratio is a surrogate marker for seed oil consumption, because most of the 6s that we have in our diet is from seed oils. So when you consume an oil, you actually absorb the oxidation products, and those oxidation products get assimilated into the body. It can contribute to oxidized LDL, which we know is bad, and it's actually been shown to lead to fatty liver disease. We've got very good electron microscopy studies that show when you deliver oxidation stress to mouse livers that you generate basically fatty liver. We've also got very good studies that show if you want to exacerbate that oxidation load from an oil, the best way to do so is with what we call glycemic instability. Basically, have your sugar levels go up and down. In this regard, they've actually done studies where they've actually looked at what we call the oxidative stress that's delivered to endothelial cells, the cells that line the blood vessels. And they've found that fluctuations in blood glucose level are far more problematic than persistently elevated but flat levels of blood glucose. They did a really nice study. This was, but what they did, they fed people oxidized oils and they had them stratified into 3 groups. Some of them were healthy, no blood glucose problems at all. Then they had well-controlled diabetics, and then they had poorly controlled diabetics. And what they actually found was that in the non-diabetics and the well-controlled diabetics, that they could measure the oxidation entering the circulation and remaining in place for 8 hours after consuming the food.
Wow.
However, in the people with poorly controlled diabetes, so they're having fluctuating blood sugar levels, and remember, this is associated with extra oxidative stress, they found an increase in blood oxidation persisting for 3 days, 72 hours. So compare that, 8 hours versus 72 hours.
Right.
And that only difference, they were having the same oxidation load in terms of oil, but they were having far, their blood sugar control was far, far worse.